All right, 5-3. This is it, people. This is the last one. Adding and subtracting fractional expressions. Let's do it right now. Here we have, on number 16, we have common denominators already, right? I mean, don't expect to see this too much. But if you have common denominators already, of course, when you add, the bottom stays the same, and the tops just get added or subtracted. So this is just becomes negative 27 plus 15 here, which is going to be negative 12. So negative 12 over 43. Here's the same sort of idea. The bottoms are both already lined up for you, so the bottom's going to be 11. So you have to have the same size piece. 11ths and 11ths and 43rds over here, and 43rds make more 43rds, if you will. So if the bottoms are the same, you just put the same bottom and add the top. So the top's going to be y plus 25. So you just write this like this. So y plus 25 over 11. And as bizarre as that looks, that is the correct answer. Now, what if the bottom isn't the same? Well, you're going to have to get common denominators just like before. 24, 24. Actually, let's back up because we could do 12, couldn't we? We could do 12 on that. 12 and 12. Don't forget that minus sign right there. So 6 times 2 is 12. So 5 times 2 is 10. And, of course, that negative sign is there. I guess that's going to be negative 10. 4 times 3 is 12, so 3 times 3 is 9. Now we're sort of back to where number 16 started with this. The bottom's a 12, and the top is negative 10 plus 9, which is negative 1. So negative 1/12. Just practice this one more time. Let's see here. This, we can go to 30s on the bottom. So this is going to be negative. This is going to be negative something over 30. Let's figure this out. So 15 times 2 is 30. So 4 times 2 is 8. So that's negative 8. And 6 times 5 is 30. So 5 times 1 is 5. Bottom stays 30. The top is just negative 8 plus negative 5, which is negative 8 minus 5, or negative 13. Negative 13 over 30 is the answer. But that party just ended when we have variables on the bottom. So let's look at how to handle this. You have to make these bottoms 5x, okay? Because there's an x found in this. You just need to put a 5 right here. So what I need to do here is multiply the top and bottom by 5. Now watch what happens. This is 7 over 5x plus 3. So this would be 15 over 5 times x, which is 5x. Now, if you think about it, that's exactly what I did. Let's back up here to number 40, for example. Here I multiplied this by 3. See that? And here I multiplied these by 2. So I've been doing this the whole time. Now I'm just multiplying these by 5s. And so the bottom stays 5x. The top is 22. 22 over 5x. Let's do another one. Let's do another one. This time you try number 60. All right, pause it and try it. See what you got. Here we have 12 and 6. So we're going to have to multiply that. We want these to be 12s on the bottom. So I need to multiply this by 2. Okay. So that's 7x over 12 plus, now what's on top? Well, it's 5x times 2, which is 10x. And on the bottom would be 12. So the bottom stays 12, and the top is 7x plus 10x. 7x plus 10x is 17x. So 17x over 12. And make sure you'd always try to reduce that if you could, but you can't. All right. Now, let's look at one of the hardest problems in this whole book right here. This is very out there as far as pre-algebra goes, because we got 2 different variables on the bottom. So how do you handle that? Just real quick, if we look at something like, let's say 2/7 plus 3, let's say, no, not 3 halves. Sorry, I'm thinking out loud here. 2, not 2 either. Let's say 1 half. There we go. And my denominator is going to be 14, right? So this is going to be 14s. Like so. That's how I would usually set that up. And I would have to multiply this by 2 and this by 7 to get these new numbers. So this would be a 4 and this would be a 7. So if I was doing this problem, it would be 11 over 14 final answer. On this, I want my bottoms to be xy. Just like I did 7 times 2 is 14. Well, this time x times y is xy. Now here's what happens. To get xy, I got to multiply this by y on the bottom. And if I do that, this concept of 1 that I've been talking about all week, 7 or y over y is still 1. All right? So this becomes 5y, and I multiply this side by what? What do you think? It would be x. So x times y is xy. 3 times x is 3x. And my final answer would just be 5y plus 3x over xy. Now, you should probably go back and watch that again. And I got another one here that I want you to try. All right, so pause it, and you try that one right there. All right. So on this, just like before, this time it's minus. I'm going to have xy's on the bottom. I'm going to multiply this by y, and this by x and x to get the xy. So this would be 6y, and this would be 4x. So I would have 6y minus 4x over xy. Final answer. I hope you've enjoyed 0910 rather. Have a good one.